So I left the last video on a little bit of a cliffhanger where we were looking at this multi-step synthesis. And I had said, that we could accomplish converting this alkyne to an alkane through a reduction process. So let's just review real quick from the previous unit, the addition of hydrogen across a pi bond. So we took an alkene, reacted with hydrogen and some metal like palladium, platinum, or nickel, and that added hydrogen across the double bond to make an alkane. Well, we could do the exact same thing with alkynes if we take hydrogen and a metal like palladium, platinum, or whatever. We use an excess of hydrogen so that we can hydrogenate all of the double bonds. That will reduce an alkyne to an alkane. So if we take a triple bond and hydrogen and a metal, it will do a complete reduction of all of the pi bonds. Now, synthetically, it would be nice if we could stop at the alkene, because what happens even if we try to, carefully monitor the stoichiometry? What if we only had 1 mole of hydrogen? There's no way that we can control the reduction stopping at an alkene by just using hydrogen and metal. But if we change up the catalyst a little bit, we can take an alkyne, still use hydrogen gas, and something known as Lindlar's catalyst. Now, you don't need to know what the structure of it is or anything. You could do a quick lookup on it, but it's this catalyst will not only stop at the alkene, but if it's possible, it will reduce an alkene to a cis alkene. Now, the reason I say it's possible is because if, like, we started, for example, with a terminal alkyne and we used H2 and Lindlar's catalyst, it would just stop at the alkene. There's no way for that to be cis or trans. But this is really interesting because we're doing a stereospecific reduction of the alkyne to a cis alkene. Now, if there's a way to make a cis alkene, there's got to be a way to do a trans alkene. And this is known as what's called a dissolving metal reaction. And this will reduce a alkyne to a trans alkene. And it's called dissolving metal reaction because we literally dissolve a metal in liquid ammonia. Usually we use sodium metal or lithium metal and put it in liquid ammonia. Again, that has to be done at very cold temperatures. But this will allow us to reduce an alkyne to a trans alkene. So these, again, a few more tools to put in our toolbox. Um, and again, make it easy on yourself. Right now, if we have to make a cis alkene, there's only one way that we know how to do that. Start with an alkyne and add hydrogen within there's catalyst. If we want to make a trans alkene, there's only one way we know how to do that. And that's to start with an alkyne and use the dissolving metal reaction. So in our next video, we're going to look at our reactions that we saw or that are going to be similar to what we observed with alkenes.